Hello everybody, welcome to week 4. This week we're going to continue with factoring trinomials. Now previously when we've looked at trinomials, we've looked at things like this one, where we decided that we could split this up by looking at 24 and thinking about those pairs, 1 and 24, 2 and 12, 3 and 8, 4 and 6, and deciding which one of those things would add to this middle term but multiply to this end term. Now, knowing that this is a negative on the end means that one of these has to be positive and one of them has to be negative. So that being said, I couldn't really use 4 and 6 because one of them has to be positive and one has to be negative. That would not get me to 10. So this one's going to be out. And the only one I can use is this 2 and 12. So in order for this to be a positive 10, or sorry, a negative 10, the negative would have to go with the 12 and the positive with the 2. And last week we even talked about how now that this is like this, we can use the zero product property to split this up into the two cases of x plus 2 equals 0 and x minus 12 equals 0. So x must be negative 2 and x must be positive 12. Now, sometimes the type of, sorry, lost my word there for a second. The type of trinomial that we're getting does not have just that one out front. So when you looked at that previous question like this is really like an invisible 1 right here. And so that makes it really easy to split this up and do what we need to do in order to factor this and find the solutions. But it's a little bit harder when that number out front is not 1. So, for example, if we have something like 3p squared minus 2p minus 5 equals 0. Now, we've talked about before how you can use factoring when you've got binomials and use the box method when you're taking binomials and multiplying them together. If I wanted to, I could kind of reverse that process to find out what this would become. So if I think about taking this, and I know I'm going to have my binomials on the outside, I know that in the end, I'm going to end up with this negative 5 right here. And in the beginning, I'm going to have 3p squared here. The only problem is I need to get these two, whatever they are, to be negative 2p. So whatever that is. So how do you make that work? So then you have to look at like, okay, so if this was 3p and p, you could get this to be 3p squared. And the only thing that multiplies to 1 and 5 are 1 and 5. So we can look at, all right, so if I add 1 and 5, can I put it like this? Well, let's see. If we did that, then I'd have 15p here and 1p here, and putting those two together would not be minus 2p. So we're going to have to get rid of that. That wouldn't work. Well, what if I put the 5 over here instead and put the 1 here? Then I'd have 3p and, and 5p. I did do that, right? Now, this is getting closer because this could get me to 2 if this had been a negative 5 to begin with. So you can see now that when I split these up, I'd have this, and this is a positive number right now, so I'm going to leave it like this. And now I have these two cases where I could take and figure out what the two values are equal to. But I will say that this process of doing this is a little bit complicated for students. They have a hard time figuring out what that is. And an even harder time when the number out front and the number in the end aren't easily figured out like this. So, for example, if I have something like 9k squared plus 66k plus 21, and I was to try to reverse that process. Well, okay, I know I need this to be a positive 21, and I know I need this to be 9k squared. But here's the deal. Yes, it could be with this 21, is it 1 in 21? Is it 7 in 3? There's multiple pairs that work to make this one true. And then with 9, is it 1 in 9? Is it 3 in 3? Like, how do we figure that out? And you can do it. You just kind of play around with it a little bit until you find out what works. So if I was to try like 3k and 3k, well, that would give me 9k. And what if I try 3 and 7? All right, well, then that would get me 21k. And here's another 9k. Well, those things don't get me to 66, so that's not going to work. All right, so maybe it's because the numbers are really small. So let's try going with 1k and 9k. How could I get to 66? Well, can I use the 3 and 7 again? Do I have to use 1 and 21? So let's try to figure that out. This would be 9k squared still. This one would be 3k. This would be 9k times 7. There's 63k. Oh, okay, great. Now we got something that makes a 9k squared plus 66k plus 21. Awesome. So yes, you can do it this way, and you can figure out eventually what those things are equal to. I have a method that I use that's a little bit different, that I prefer, because I think it helps you to be more straightforward and the steps are more concrete than kind of this like abstract thinking that has to happen. If you like doing it this way and this way is good for you, go ahead and do that. Otherwise, I'm going to show you something that's called the ninja trick. And what I would like you guys to do is, if you're watching this video, I would like you to go to section 3 of your binder. And I want you to take notes on how to do this trick. All right, so let's go back to our original example. We had 3p squared minus 2p minus 5 is 0. Okay, here's how the ninja trick works. Ninjas, they disappear and reappear. That's why it's called the ninja trick. We're going to make this 3 out front disappear. And we're going to do that by taking this 3 and multiplying it by the back term. Now, normally you can't really do something like that because, you know, that they're not equivalent. This and this are not equivalent things. But wait and see. I'm going to show you like why this is acceptable to do it this way. Now, if I have no number out in front, now I can easily split this up like we were previously doing. Things that multiply to 15. Well, 1 and 15 and 3 and 5. I know I'm going to have to get to use 3 and 5 in order to get this negative 2. And it's going to be negative 2 if I make this negative 5 and positive 3. Okay, and the whole time I'm just following, bringing this 0 down. Okay, so your first step was to multiply. Now that you've done that and you split it up into the two factors, what you do is it went away by multiplying. It's going to reappear by dividing. I take each of these numbers and I divide by 3. In the first case, 3 divided by 3, that divides evenly. So this is just p plus 1. In the second case, this does not divide evenly. So what I do is I bring this 3 in front of the p. And now this is the same thing that we had before when we were doing this using kind of that reverse box method. And I would still have p equals negative 1 and p equals 5/3, just like I did before. Okay, so let's use that again, but now for the second one that I showed you. So we had 9k squared plus 66k plus 21 equals 0. Now, this one's going to be a little bit trickier because now we've got some pretty big numbers here involved. For example, if I take and I do 9 times 21 in order to make it disappear, I get 189. As you can imagine, there's a bunch of things that could go into that. But not very many of them are going to be 66 apart. And since these are both positive, they have to add to be 66. So I kind of just start looking. 189 divided by 2 wouldn't work evenly, so how about 3? Oh, 3 and 63. First thing we have. 3 and 63 would add to 66. 3 and 63. I'm going to have both these positive. And now I made it disappear by multiplying. Now I'm going to make it reappear by dividing. Okay. A couple of things here. This time, these do not divide evenly, but this does reduce. This is the same as 1/3. This one does. So I'm just going to divide that. Now, since this is still a fraction, I'm going to bring this 3 out front. 3k plus 1 and k plus 7, just like we ended up with before. Just a little bit more of a concrete way to get your answers and not have to fiddle around so much with what makes what makes what true and how can you get each thing and so on and so forth. So I'm going to give you a new one. Do maybe one more together and then move on. So how about you try? Let's do 5n squared plus 19n plus 12. And I'm going to have you guys stop here for a second and then try it. Okay, so hopefully you remember that the first thing to do is to multiply these two. So n squared plus 19n plus 60 is 0. Things that multiply to 60. 1 and 60, 2 and 30, 3 and 20, 4 and 15. Oh, 4 and 15 gets me to 19, so I'm going to use that one. And everything's positive here, so I know all my signs are going to be positive. And I got rid of it by multiplying, so I make it reappear by dividing. This would not divide evenly, so 5n plus 4. And this one does divide evenly, so I just rewrite it. So this would be n equals -4/5 and n equals -3. All right, one more before we move on. Stop here for a second, see if you can get it. Okay, again, first thing you should have done is to multiply. So n squared minus 8n plus 12. And now I split that up into the two cases. The only things that would work that multiply to a positive 12 and add together to be a -8, well, 1 and 12, 2 and 6, 3 and 4, 2 and 6 are going to be the only things that work. And they would have to both be negative to get me a -8 and positive 12 when I multiply. From here, divided by 3 to make it reappear. So 3n minus 2, because these two do not divide evenly, and n minus 2. So n is 2/3 and n is 2. Okay, moving on. So what we're going to eventually get to talking about is the different forms of questions, and like when you're given different questions that they're basically asking you to factor, how do you decide which one to use? So for example, when I'm looking at something like this, versus something like this. Or something like sorry, this. Which method do you use and what would you get? So notice in this one, there's nothing that each of these has in common. There's no perfect squares. There's not a number out front. So this one would be something like simple factoring. Just take and split them into the two cases. This one has this 3 out front. That's going to trip you up. I also can't take 3 out of each of these terms. So I would say with this one, you'd want to use the ninja trick, the one that we just did. This one, this is a perfect square, and this is a perfect square. So I would use the perfect squares form. So with this one, this is the one where you'd have 2x and 2x, and this 81 is 9 times 9. So I would have plus and minus, and they're the exact same thing. In this one, each of these terms, I can factor out a monomial term that each of them has in common. I'm going to factor out a GCF, greatest common factor. Each of these, a 5x would come out of. And I would have this would become this. So these are 4 methods, right? 1, 2, 3, 4 methods that we've talked about so far. There's one, though, that we haven't talked about yet. And the one that we haven't talked about yet has to do with square roots. So I would continue with your notes. We're now going to move into a section called, that I would just put square roots at that part, so you recognize the difference between the 2 methods that we're going to talk about today. So square roots is used when those other methods just aren't going to cut it. And you have something like n squared minus 5 equals, let's make this something easier. About minus 9 equals 0. Now, you could, this is a product of perfect squares, so you could just split this up, because n would be n, and 9 would be 3 and 3. So I'd have plus and minus, and that would be equal to 0. So I'd have n equals negative 3 and n equals positive 3. However, this n squared and just this number here can be done another way. If I was to get this n squared by itself, I'd have to add 9 to this side, and I'd have n squared equals 9. And in order to get this n by itself, right now this n squared is n times n, right? The opposite of a square, we talked about this in class a couple of times, is a square root. I would have to take the square root of both sides. Taking the square root of a square just gets you 1 of the number multiplied by itself. And now with this 9, there are 2 ways that you can square a number and get 9 as a result. That's if you have a positive 3, 3 times 3 is 9, or a negative 3. Negative 3 times negative 3 is also 9. So I write that plus or minus 3. Let's look at another one. If I had something like n squared minus 5 equals negative 4, how do I get this n by itself? I would add 5 to both sides. So if I did negative 4 plus 5, that's just 1. What things can you square and get 1 as an answer? Well, you can square positive 1 and negative 1. you keep going. What if you had n squared plus 8 equals 80? Well, if I was to move this 8 over, I'd have to subtract 8, and 80 minus 8 is 72. If I take the square root of both sides, I'd have n equals, but this isn't a perfect square. Remember, those perfect squares are all the numbers that multiply them by themselves. They're all the doubles that you talked about when you were really young and learning to multiply. 3 times 3 is 9. 4 times 4 is 16. As you get up here, you've got 8 times 8 is 64. 9 times 9 is 81. So you kind of like totally skip this 72. There isn't a number that this would easily be. So for this one, you could, though, say that if I was to take that square root of 72 and square it, I could end up with 72. But I would also have to keep the case of plus or minus, right? Because in this case, if I took the square root of 72, I almost wrote 27, and I squared it, I would get 72. And if I took the case of negative 72 and I squared it, I would get 72, what this was originally. Right? So it's possible for you to get answers that are like this. What about something like 7v squared plus 1 equals 29? All right, let's focus first on moving that 1 over. So if I subtract 1 from both sides, I'd have 7v squared equals 28. And now I'd have to divide by 7 on both sides. So v squared equals 4. So if I take the square root of both sides, v would be plus or minus 2. So if there's something like however you need to do this in order to get the v by itself, just go ahead and do that. But there is something that's kind of interesting to note, and that's with square roots, you end up with kind of 3 cases. First case. First case is you have something where, I don't know, you have maybe v squared minus 10 equals 21, something like that. And you add the 10 to both sides, you get v squared equals 31. And you take the square root of both sides. Well, then my v would be plus or minus the square root of 31. In this case, I end up with 2 real roots. And that happens if I have something as simple as this, or going back to an earlier example, if I had something that was just like this, and I ended up with taking the square root of both sides, v is plus or minus 3. That's still 2 real roots. The other case is, what if I have something like this? And I bring this 9 over to the other side. Well, I would add 9 to both sides, so I'd get v squared equals 0. And if I take the square root of both sides, v, the square root of v squared would be v, and the square root of 0 is just 0. I don't have a positive and negative case in this one. So with case 2, you get 1 real solution. If I said real root in the other one, roots and solutions are kind of interchangeable words. Okay. Third case. Third case is, well, actually, there's technically, I guess, 4 cases then. The third case is something like n squared minus 15 equals negative 11. If you were to subtract this 15 from both sides, you'd get n squared equals negative 26. And when you take the square root of both sides, your negative is now on the inside of the square root. And we can't really do that because that's going to result in an imaginary number. When you take the square root of a negative, that's an imaginary number. So this one has no real solution. Like that. I guess it's not really 4 cases, it's just part of this third case. I'm just going to say that that's true even if you have something like n squared plus 4 equals negative 12, and you subtract this 4 to bring it over to the other side, and now you've got negative 16. Yeah, negative 16, you can take the square, or this 16, you can take the square root of, right? That's a perfect square. But this is still a negative. So when I try to take the square root, it's still no real solution. Okay, so we covered 2 topics today, 2 little topics. The first one is the ninja trick for if you've got a number out front and you're trying to get them to factor. And the second one is square root solutions. I want you guys to try the worksheet that I'm going to assign for tomorrow. And if you're feeling like really stuck, and you also take a look at the IXLs that I'll assign for this week, make sure that you reach out on Tuesday and Thursday at our Google Meet from 10 to 11. Make sure you come and ask questions if you get stuck. Okay? All right. Reach out in the meantime if there's anything I can help you with, and I hope that you guys are safe and well. Bye-bye.